So, adrenal gland. I refuse to talk about adrenal medulla. In Anatomy and Physiology 1, we discuss the function of adrenal medulla when we talk about autonomic nervous system. So what you need to understand, a lot of, I'm not asking you to know this term, parenchymatous organs. Parenchymatous mean organ that doesn't have a cavity. You see what I'm saying? Like adrenal gland, kidney, liver, so those are parenchymatous organs. So many of them, not all of them, you can clearly see two functionally and structurally distinct layers: superficial cortex and inner medulla. Even in the brain you have cortex, right, on the surface. In kidney you have cortex on the surface. In lymph node you have cortex. So same goes for adrenal gland. You have outer cortex and inner medulla. So medullary hormones are water soluble. All of them. There are actually two: epinephrine, norepinephrine. Okay? Cortical hormones, all of them, no exceptions, are lipid soluble. As a matter of fact, they all are steroid hormones. Okay? Now, anatomically, there are three layers in the cortex with particularly easy to pronounce names. And if you go from zona glomerulosa, zona fasciculata, and zona reticularis, I was just kidding. So each zone, each layer produces its own unique hormone with its own unique function. Does that make sense? And we're going to start with the outermost layer, the zona hold on, let me think. That one's zona glomerulosa? No, I actually want to do zona fasciculata first, the middle one, to connect it to the previous conversation, okay? So we just talked about thyroid hormone, right? So now we're going to talk about hormones produced by the middle zone, zone fasciculata, of the adrenal cortex. Okay? Now, check this out. It all starts with a stress. Stress stimulates hypothalamus. Okay? Which releases corticotropin releasing hormone. Okay? Now, corticotropin releasing hormone acts on anterior pituitary, which produces corticotropin, which bears another name actually, adrenocorticotropic hormone, or ACTH. Okay? So far so good? And it acts on the adrenal cortex, which releases a hormone called cortisol. Okay? So far, does that make sense? So this is called hypothalamus pituitary adrenal axis. Let's figure out what the responses are. You are under stress. Stress is a very broad concept. It can be physiological, like being deprived of movement, being cold, can be psychological. You all know that, okay? So, but let's just kind of step away from our modern humans' experience and just think about, like stress in survivalist sense. When you are stressed, like maybe there's not enough food, you've been attacked constantly under threat of being eaten by predators and shit like that, okay? So, in order to fight stress, do you need energy? Yes. You already mentioned, what are two molecules that are main sources of energy? Lipids and carbohydrates. So, the outcome of increased cortisol release will be elevated blood glucose, okay? And in terms of lipids, you're going to have elevated blood fatty acids, which will be a result of lipolysis. So this is something. Now remember, I'm gonna try to connect new things to the previous experiences. Which other hormone had kind of similar outcomes? Say again? Growth hormone, yes. So both of them will result in elevated blood glucose and lipolysis, which leads to elevated blood fatty acids. Does that make sense? Remember we talked about how bad this is? So elevated blood glucose, what it will lead to? Yeah, so people who are constantly under stress, and I'm talking like psychological stress, like, I don't know. Well, good example here. We can argue what's the most stressful job it is, but second-hand story, I know a guy who knows the guy. Brokers, traders at the New York Stock Exchange, a buddy of mine worked there as an IT specialist. He saw those people. It's constant stress. Like their work is a quintessence of the stress. That makes sense? They make a lot of money. They retire in 4 or 5 years with diabetes and atherosclerosis. That makes sense? They constantly producing like a ton of cortisol. Obviously, this stuff does not alleviate stress. It helps you to respond to this. Am I clear? Now, a couple more details that I want to add here is this. How can you increase your blood glucose? There are 2 ways. How can you, if you don't have enough money, how can you, and not spending money is not an option, right? So if you don't have enough money, what are 2 options that you have to increase the amount of money in your wallet? Can you earn more? Yes. So this is called gluconeogenesis. You should start learning this terminology because I will ask this. Gluconeogenesis. Look, making glucose from scratch. Glucose, genesis, making, neo from scratch. Also, can you tap into your savings? Yes. So you can tap into your glycogen storage in the process of glycogenolysis. Okay? Multiple typos, hold on a second. Okay, so glycogenolysis. See that? Gluconeogenesis, glycogenolysis. Okay, we're good so far? Awesome. And as usual, we need to establish our link here. So just as before, cortisol inhibits hypothalamic release of CRH and release of ACTH from anterior pituitary gland. Okay? That makes sense? I don't know if you've experienced that, but one of the effects of prolonged chronic stress, and we're talking about chronic stress, is weight loss. It's pretty well known. Okay? That makes sense? Now, here's another question that I have for you. We found some parallels between the cortisol as a stress hormone and growth hormone. They both induce elevated blood glucose and elevated blood fatty acids, basically stimulate making glucose and breaking down lipids, right? Now, one big difference, cortisol results in a protein breakdown. So, in this instance, it is an opposite to the growth hormone. Am I making sense? So what I'm trying to tell you, if you try to grow, time of stress is not the best time for it. Because all your resources, including proteins, will be used as the energy source. Okay, so breakdown of proteins, amino acids will be used as an energy source as well to make glucose. Okay? Make sense? So that's the difference. Growth hormone will stimulate protein synthesis and while the cortisol will inhibit protein synthesis and will increase protein breakdown. Regarding this, make sense? So what are the diseases? Cushing's, a lot of cortisol. Addison's, too little cortisol. So in Cushing's, what happens? Metabolism goes awry, and basically people with Cushing's are actually obese. They aren't genuinely stressed. They just overproduce cortisol. Does that make sense? Now in Cushing's, where cortisol levels are high, how you can expect CRH and ACTH levels to change? They will decrease, and in Addison's it's going to be the opposite, right? So in Addison's, cortisol is low, ACTH is high, CRH is high. So Cushing's is like obesity, swollen face, so-called buffalo hump, the accumulation of fat here at the back of the neck. In Addison's, usually very low energy. The famous person at Addison, I have a picture of JFK before and after treatment. John Fitzgerald Kennedy was on glucocorticoids for his entire life. Well, since they started treatment. Okay, does that make sense? Good? Okay.